Okay, so we're continuing to look at the AP review. These are multiple choice cumulative problems. So starting with 13 here. The graph of functions f and g are shown. H of x is defined as f of x plus 4 over g of x plus 2x. Find h prime of 3. So if we want to find h prime of 3, we look at how h is defined. H is defined as numerator over denominator, so we have to go through quotient rule to find the derivative. So f prime g minus fg prime all over g squared. Okay, so f prime of the numerator expression, f of x becomes f prime, 4 goes to 0. G of x stays the same as the entire denominator, minus the original f of x function, the entire numerator, times the denominator's derivative. So g of x becomes g prime, and then 2x becomes 2, all over denominator squared. So now we can start filling in the x's with 3's. So here we have the results of replacing all the x's with 3's. The next step is we have to be able to use the graph to help us find replacements for f prime of 3, g of 3, f of 3, and g prime of 3. So f of 3 and g of 3 are just ordered pairs on the graph. So we see f of 3 is simply 4, g of 3 is going to be 2. But f prime of 3 and g prime of 3, now we're asking about this derivative, which is in this case, visually it's just the slope. So the slope of f of 3 is just going to be the slope of this line. So if I can just find 2 points on this line and just do rise over run, up 1 over 2. So f prime, the slope of this line where 3 resides, is going to be 1/2. And the slope of the g graph at 3, we see that it's part of this negative slope line. And if I can pick 2 points on this line and do rise over run, I choose these 2 points. So I do down 3 over 1, that's negative 3. So once we have our ordered pair and our slope, we can just plug all those values in. So f prime of 3, g of 3, f of 3, g prime of 3, and g of 3, they all get replaced with what we found. And then we just try to clean this up. So 1/2 times 8 is 4. 8 times negative 1 is, the 2 negatives becomes positive, all over 8 squared. Clean this up, we get 12 over 64, which is 3 over 16. Okay, for number 14, let f be a differentiable function. So again, differentiable means it's a smooth curve, no sharp turns. Okay. H of x equals 1 plus f of 3x quantity squared. Which of the following gives a correct process for finding h prime? So something we have to be able to see that this there's a bit of a chain rule going on here. So the original chain rule looks like this. The derivative of f of x, f of g of x, is the outside's derivative, the f prime of g of x, times the inside's derivative times g prime. But if you look, there's actually 3 different layers within this h of x function. You got the bracket, what's in the bracket squared, that's the outermost function. You have the 1 plus f of 3x, that's the inside function. And then there's the innermost function is what we see inside the f, which is that 3x. So we basically have to now take turns with each of these 3 derivatives, one at a time. So let's take care of the outer first. So the outside is 2 bracket to the first power. We fill in the bracket with what was originally there, no changes, multiplied by the inside function. So now we have to look at these 2 terms derivatives. So 1 goes to 0. F of 3x becomes f prime of 3x. Okay. And then we look at the innermost function, which is that 3x. And the derivative of 3x is going to be 3. So now if we just try to push some of these together, put the 3 and 2 together, I can make it 6. But in this case, looks like this form is going to match best with whatever form we see in the answer choice, so answer choice D. All right, number 15, the graph of the decreasing differentiable function, again, smooth curve. F of x is shown, so f of x is shown with this curve here. Also shown is the line tangent to the graph of f at 0.46. So this line is tangent to the graph at this point. Now what that tells us is that the slope of the curve at this point is going to be the same as the slope of this line, of this tangent line. Okay, so that's the definition of tangent line, is that this tangent line is going to share the same slope as whatever that slope of that curve is at that point. Okay, let G be the inverse of f. Which of the following statements about G prime is true? So we don't see G in front of us, but we do know that G is the inverse of f. So let's explore that relationship between f and g if they are inverses of each other. So recall that f and g, if they are inverses of each other, the slope of the f and slope of the g are going to be reciprocals of each other at their corresponding points. Okay, so if we look at this order pair for f, this order pair of f is order pair 4, 6. Now we don't see g, but we know that if g is a true inverse function of f, then on the G graph, there must be an order pair that is 6, 4, right? And that's just order pair relationship between a function and its inverse. Now, we want to figure out which of the following of G is true based off of this. So if f is in front of us, and if we can figure out the slope of the f graph at 4, which we can, because we can just figure out the slope of this line, which is, if I pick 2 points on this line with the negative slope, it's down 3 over 4, rise over run, down 3 over 4, so slope of negative 3/4. So even though we don't see our G graph in front of us, we know that there is that relationship between if 4, 6 sits on f graph, then 6, 4 must sit on the G graph. And if the f graph has a slope of negative 3/4, then the G graph at 6 must have a slope of negative 4/3. Okay, reciprocals of each other at their corresponding points. Okay, answer choice C. 16, similar relationship here. F is increasing on the function defined by f of x, where f of negative 1 equals 2. G is the inverse function of f. Which of the following is the correct expression for G prime of 2? So we know f of negative 1 equals 2, which means that G of 2 equals negative 1, right? We know that order pairs will be flip-flopped. So the slope of the f graph is going to be the reciprocal of the slope of the G graph. So a way to represent f prime of negative 1, let's just call that slope f prime of negative 1. So I know my G prime graph is going to be the reciprocal of my slope of f prime of negative 1. And here, look at my answer choices. It doesn't give the exact value for f prime of negative 1, but it's okay. We know that this will represent the slope of the f graph, and G prime of 2 is going to be the reciprocal of this slope. So we can just say 1 over f prime of negative 1. Okay, for 17, we have y equals 2 natural log of x. This notation means find the fourth derivative. So let's see if we can work our way down. So 2 natural log of x, the rule for natural log of x, or natural log of u, is u prime over u. Okay, so if our u value is this x here, then u prime over u is just going to be 1 over x with the 2 coefficient tagging along. So 2 over x, that's our first derivative. Now, if I want to find the derivative below this, I can just go through power rule. But to do power rule, I'm going to rewrite this as 2x to the negative 1. And now we can just go through our power rule to move our way down to each of our derivatives. So 2x to the negative 1, the derivative is negative 2x to the negative 2, right? Bring down the exponent, subtract 1 from the exponent. And then, so we keep going, right? Keep going to find each of the next derivatives. Do power rule again. Bring down the negative 2 in front, so 4x to negative 3. Power rule again, bring down the negative 3, so negative 12x to negative 4. And there's our fourth derivative. Let's clean this up to make it match our answer choice. So answer choice B. Okay, for 18, the figure shows f prime, which is the derivative of the function of f, at which of the 4 indicated values is f double prime the greatest. So we're asking, when is concavity going to be the greatest? So we're looking for the largest possible value of concavity. Now, remember that we're looking at the f prime graph, so the curvature is not going to be how we interpret concavity. If we're looking at the f prime graph, the concavity or the f double prime value is determined by the slope of the f prime graph. So we're basically looking for what is going to be the greatest slope of this f prime graph. Whichever point has the highest value slope is going to be the one that has the greatest concavity. So in this case, this looks like a slope of maybe 0.1 or 0.2. It's going to be a very gradual positive slope. This looks like a positive slope of maybe 3 or 4. Is obviously a much steeper than this, and also in the positive value. So far, this is the largest, greatest value. That's a slope of 0, and that's a really steep slope in the negative direction, right? That's a negative, maybe -5, -6. Either way, these are the only positive slope that we're dealing with are these two, and this is obviously a greater positive value than this one. So basically, point B, since point B has the greatest slope, positive slope, it must be the point with the greatest concavity because we're looking at our f prime graph.